So we're going to talk about how to simplify rational expressions. That's something that looks like this. So a rational expression is a ratio of two polynomials. First, we're going to talk about how to just simplify fractions because it's really a really similar process, so we're just going to review. If I want to simplify 16 over 30, I'm basically going to write out all the prime factors of 16, and then I'm going to write out all the prime factors of 30. This is this first step, factoring the numerator and the denominator. And then I'm going to cancel the common factors. So 2 and 2 are on both the numerator and the denominator, therefore I can cancel them out. And then finally I'm just going to simplify by multiplying them back together. 2 times 2 times 2 is 8, 3 times 5 is 15, and so then I have a simplified fraction. Instead of 16 over 30, I have 8 over 15. Obviously, we don't do that every single time, but this is basically the process behind what we're doing in our heads every time that we simplify a fraction. We're factoring the numerator and denominator, and then we're canceling common factors, and then we're simplifying. So we're basically going to do that exact same thing, but with the rational expressions. So first things first is we are going to factor the numerator and the denominator. So x squared plus 5x plus 6 can be factored into x plus 2, x plus 3. And then I'm first going to pull that x out of x cubed plus x squared minus 6x to get this. And then x squared plus x minus 6 factors into x plus 3, x minus 2. Cool. Okay, so now I have that in factored form, and this is a new step that we have to do when we're taking into account rational expressions. Is at this point we have to list the restricted values. So we have to remind ourselves that the denominator cannot be equal to 0. When we're just dealing with regular fractions, that's never going to be the case. We don't really have to worry about whether denominator is 0 or not, because we're just not going to have one with denominator 0. But when we have rational expressions and x's, we have to think, when is the denominator equal to 0? So in our case, the denominator is equal to 0 at x equals 0, x equals negative 3, and x equals 2. So these are our restricted values. Basically, x, because this is where the denominator is 0, we know that x cannot equal 0, x cannot equal negative 3, and x cannot equal negative 2. Otherwise, our denominator would be 0, which would be undefined. Okay, so now that we know that, we can go back to our process and work towards canceling the common factors. So I have my expression here, and basically I'm just going to look for factors that are in both the numerator and the denominator. So I see x plus 3 is in both, cancel that out, and it looks like there are no other common factors in both the denominator and the numerator. And now I'm just going to simplify this. X plus 2 over x times x minus 2, and then I have to remember to pull down my restricted values. Now, if we had looked for restricted values only in the simplified form, like if we had done all of this and then we said, okay, what can x not be? We would have gotten x cannot equal 0, x cannot equal 2, and we would have missed out on the x cannot equal negative 3 because we canceled that out. But because we started with this and x cannot equal negative 3 here, it still cannot equal negative 3.